All right, so this is a case study on a 2010 Jeep Compass. Apparently, this car has been to a couple of garages. It actually started out with a transmission complaint. It was looked at by another shop. They actually put a rebuilt transmission in it, and then they sent it over to the dealer for programming, that kind of stuff, setup, whatever had to be done to the vehicle when a transmission replaced. It is a CVT. Anyway, to make a long story short, customer got the car back. The transmission still wasn't acting properly. Check engine lights on, and they were somewhat afraid to drive it for fear of damaging the new transmission, because apparently the sort of the old scenario with this car was check engine light came on, and then the transmission kind of gave out in it. So we started off this same way we would normally would. Now this is a fairly quick case study, and it wasn't really all that hard to figure out, but we did a quick scan for codes, and I'll show you the code screen here in a second. But it had a P0032, which is an O2 heater high code. It had a 647 code, which is an AC control circuit high code. And it had a 2010 intake manifold runner control circuit high code. Now, all three of these codes are showing as circuit high. It's typically, in our experience anyway, when you get circuit high codes, usually you're dealing with some kind of a ground problem or something like that. So we're going to quickly take a look at the codes here. I'll show you the code screen in a second. Then we're going to go in and do some testing on one of the circuits. Now we took, we went after the intake runner circuit simply because it was the easiest thing on the car. Looking at the car, it was the easiest thing to work on. And our thinking typically when we get codes like this is all of the codes have the same fault. It's highly unlikely that there's three different problems with this car. Typically, what we're looking at here is one problem causing the three codes.
About the time that we decided to take a look at this car, we also received a new Autel Ultra scan tool in, so we decided to kind of use it as our scan tool for this thing. Got a couple of nice features. I like this one. We went in and we did a network scan. This is a new feature, and this is kind of the display we got doing the network scan. You can see here that the central gateway and the ECM both have codes in them. Got a bunch of modules that are showing green, which means they're online with no codes. And then we've got a couple of grayed out modules, which are basically either not responsive or not built onto this vehicle. And for the time being, we're going to call them as being not built onto this vehicle. After looking at the network, we decided to take a look at the codes. So what you're looking at here is the code screen. So we've got three codes in the powertrain control module and one in the central gateway module. All of them are circuit high codes. Now, circuit high codes, usually when you get a lot of them like this, circuit high codes simply mean that the voltage on any given circuit is higher than the PCM or the module expects it to be. So in this particular case, we've got 4 different circuits showing voltage high codes. Typically, I think I stated this earlier, but you don't see multiple failures all happening at the same time unless there's a connection. And I suspect that we've got a problem with the ground to these particular sensors or circuits. So the first thing we're going to do is we're going to go in and we're going to take a look at a wiring diagram, see where the common connections are, and then we're going to start to do some testing. Now, when I started to look at testing on this thing, we took a look at the intake manifold runner circuit, and the only reason we kind of picked on it was because it was the easiest thing to get at on the car. So we're going to do all of our testing on the intake runner control circuit. Now, in order to set the vehicle up for testing, we went into the active test or the bidirectional test menu for this car. Again, we're still using the Autel Ultra here, which I really like. And we were able to find a list of things that we could turn on and off. Interestingly enough, the intake runner control valve, they've got it labeled as the flow control valve. Anyway, kind of a small annoyance more than anything else. We were able to go in and we've got the option to turn it on or turn it off or toggle. Generally, when we're going to do this type of testing, we'll select toggle, so the computer will just keep turning the thing on and off. Makes it kind of easy to test. So that's what we've done here. And then the next thing we need to do is once we know that we can turn this thing on and off very easily with the scan tool, the next thing we need to kind of do is go and take a look at the circuit we're going to test, and then go ahead and test it. So this is the wiring diagram for the flow control valve. I'll just kind of explain how this works very, very quickly. There is a sensor in here. This is feedback. So this is a sensor ground. It's obviously a potentiometer of some sort. So this would be the 5-volt feed to the potentiometer. This is the feedback signal right here. So this is where the computer, this is what the wire that the computer is looking at to gauge the position of the flow control valve. And then finally, I've got the solenoid that drives the valve. So what I've got here is the control signal and ground. Because this thing is permanently grounded, that would mean that this thing is power side operated or power side switched, which means the voltage on this wire should be fluctuating between 0 and approximately battery voltage. And the voltage on this wire, because it's a ground, should be pretty close to 0. So that's kind of what we're looking at, or what we hope to see when we actually get our scope hooked up and start testing the circuit. So this is how we hooked the scope up to take the screenshots you're going to see coming up here in a second. The orange trace at the top there is on the control signal. We expect this to be a pulse 12 volt, and the green trace is going to the flow control valve ground circuit. We expect this to be pretty much at ground voltage level all the time, which means it should be right around 0. So now that we've got our scope hooked up, let's go ahead and start cycling the valve. You can see what happens next. So what we see here on the orange trace is the computer is indeed applying a pulsed 12 volt on-off type signal, which is what we expected to see. But the ground circuit, the green trace, which should be at 0, is bouncing up to, it is over 12 volts, which indicates that the ground on this thing is very bad. So our next step is to find the ground where the circuit is actually grounded, inspect it, and if that's okay, we're going to work our way back to where the problem is. But with some simple testing here, we've already identified that we've got a bad ground on this thing, which didn't take all that long. So let's go and see if we can find the ground. So here's the ground on this car. We're going to go ahead and fix it up and retest it and see where we're at. Now when we look at the ground circuit voltage after repairing the ground, which is our green trace here, we can see that it's at a solid 0, which is exactly what it's supposed to be. And the only thing left now is to go clear the codes and then go in and take a look at the codes. You can see here from our code screen that the codes are gone. We road tested it, they didn't come back. So we're going to call this one fixed by repairing the bad ground. Until next time, guys, have a good one. If you like this video, please let us know by following us or liking us on Facebook, Instagram, Twitter, and YouTube. And if you want access to more in-depth training videos, please visit our website at www.autoaide.ca. Thanks for taking the time to watch this video.